go. Okay, hello everyone, and welcome today to Altair Insights podcast. We are joined by Randa Milliron, who is a special individual. Since 1995, Randall has been a co-founder of Interorbital Systems and has served as the company's CEO and director of marketing. Her professional experience spans across aerospace, broadcast media, the arts, and academia, so all-rounded expertise that she has. She holds a bachelor in psychology, a master's degree in African languages and area studies. Very interesting. So I'd love to learn how you're tying that as well in your work that you do every day with the interorbital systems. She is also a doctoral candidate at Humboldt University in Berlin, with additional studies in chemistry at Cal Poly Pomona, California. And she's mainly handling interorbital systems regulatory, sales, promotion efforts, STEM outreach, and on the engineering side, she also specializes in the development and use of high temperature composite materials. Wow, I mean, that's a lot just by reading and looking at it. That's a lot, Randa. And again, congratulations to you for handling all of those operations as successfully as you are. So,
yeah, we work. We work as a small rocket team here, and the philosophy is everybody has to be ready to do everything. So we switch off on a lot of tasks, and whenever something needs to be done, everyone pitches in. So it works that way.
Good. So keeping the startup mentality.
I'm not the only one doing the multidisciplinary thing. Everyone here is. So
great. So keeping the startup mentality, and obviously, and speaking of the small team, so how large is your team currently, Randa?
Right now there are 5.
Mm-hmm.
So it's a core prototyping and design team. So we've been working exclusively with a team that designs the rockets. That team also is the launch crew. Does all the testing prior to a launch, does basically everything, writes all the software. And I should say also, I think our company's pretty different. We don't buy anything. We make everything in-house. We make all our engines. We make all our pressure vessels for the rocket, every part of the rocket, down to guidance and all the software that runs everything.
And that's fascinating to me, obviously. And that's fascinating to me that 5 people are able to accomplish that. But again, if as you're mentioning, they are also as multidisciplinary as you are, I mean, then 5 people can be a strong power. And again, you're doing a good job demonstrating that. So maybe let's unpack a bit more regarding the interorbital system. So how does Interorbital Systems differentiate itself from other companies in the crowded space launch market, Randa?
Well, as I mentioned, we work as with that rocket team mentality. So there's we have a very fast interaction for ideas. We don't have to go through layers of hierarchy in order to make a change that in a dinosaur type company would take weeks or months to have approved. Because of that crazy Byzantine structure that they have. This is geared towards rapid development and interactive participation in the design and in the build. So that's one way we're different. Also, we're pretty much self-funded. We have been in existence since actually at the spaceport here since 1996, which is a while, and we have worked on again on all those systems pretty much sequentially and sometimes in parallel, but because we're not loaded with cash, I think it's been a benefit. We work in that capital constrained environment, so it forces us to innovate to make a less expensive rocket, which is what the goal has been, to make the least expensive rocket in the world, and then pass those savings on to our customers. and I guess we're different also because we actually do have paying customers. We have 190 plus small satellite payloads already booked for launch.
Oh, wow.
And many of those payloads were made from our satellite kits. We produce CubeSat kits, right? We're on the CubeSat 2.0 right now, and also the TubeSat, which was our invention. And I have some here if you'd like to see them. Here's a
Oh, that's
TubeSat.
so cool.
Yeah, and I think the first one of these went to orbit in 2017. It was actually built by a Brazilian middle school, the Tancredo Middle School in Ubatuba, Brazil. They and they sent a message of peace. And actually, the average age of the people working on that project was 11.
11 years old.
And they worked with their really innovative school staff and their space agency as mentors. So they, I wish I had been able to do that at 11.
Oh, that's impressive. I mean, 11 years old. And again, Brazil, as you brought it up, so they've been doing quite a good job lately.
Yeah.
Again, we watching from aside, obviously, but they've been quite fast developing the youth, and the interest is actually growing. There was a recent study, Randa by Inmarsat, and actually they figured out that over 13% of the youth in Brazil, they want to pursue a career in the space industry, which was much higher than that in UK and then some other countries. It was very high. So
I think they were influenced by the amount of attention that their this school generated for the country, and I think they were an inspiration. So we were happy to be a part of that. This is this is our CubeSat, a more standard satellite, but we offer these in a kit and launch package, and so people buy that that package. They don't have to go out seeking a launch. They just have to wait a bit longer with us. But it's for a school or for an academic group or a student, someone operating independently, they can have a launch to orbit with a CubeSat for 22,000. That's the kit that gives them a functioning spacecraft, and the launch. I think the launch is at this point probably the first one available will be sometime at the end of 2024. But again, we have I think something like our kits are used in STEM programs in more than 25 countries at this point, and that whole the build and design of the payload is the core of STEM curricula all over the world. So we're proud of that. And most of us here, in fact, all of us here are university professors or were professors. And so we're all like, we're all into that. We like that. And we like teaching people how to, what is basically guild knowledge. It's something you can't really, just walk into a classroom and learn, how to make satellites, maybe in a few places in the world, but we've made this available for people, again, worldwide.
That's awesome. Yeah, I mean, absolutely, because there's this issue of the practical. You might learn a lot of things at universities, but unless you really get this practical experience, and again, I believe that's why you were doing a great job with those kids as well. So how does it exactly work, Randa? So do you actually reach out to those academic universities, and do you again close them with the idea that they have to do it, or it's them coming your way?
They call us. We've not ever spent a dime in advertising, and we started our satellite program in 2009, and since then people just call us and order the satellites, which is great. Like I said, it's that's kind of the bread and butter of the company. It keeps the company going, allows us to do our R&D, and then we don't have to be burdened with, some giant, again, this political hierarchy of a standard corporate structure. So
yeah, so sorry to interrupt. And for some of the universities and academic institutions that are listening to this, so what would be the ballpark number that they would be looking at if they wanted to?
For as little as 16,000.
Okay, that's quite affordable.
They can get a TubeSat kit, and this kit comes with everything that allows them to customize their their own spacecraft. They have access to all the schematics, all the circuits, everything that makes this satellite a satellite. But then it allows them to, if they want to add a camera, if they want to add a propulsion system, whatever they might want to do, they can go into the actual kit, which is basically a bus, that supplies radio communication, power management, that's the solar power management, and it gives them it's an on-orbit platform that they will populate with either their experiment or their app, so they can totally have control over how that satellite is built and what it carries.
And then how are they tracking again the progress in getting the signal? So is that also part of your service, Randa, or that has to be?
We're working on developing a ground system for that, but there are a number of free systems around the world that are serving academic groups, and we work with we're currently working with Atlas Space, and they have a ground system complex, around the planet, and we're looking at potentially making that academic class of satellites trackable potentially through them. That's still in work at this point, but that's something that we're considering. We're also looking at designing a ground station kit. That's also in work for those who want to build their own ground station. But these satellites can be tracked, with a handheld Yagi antenna, and they run on the amateur band. So the amateur radio band is any kind of amateur radio equipment is good. But the kits, I guess, are also secretly team building exercises. So if the group is building satellites, so now what do we do? How do we track it? Well, then they'll probably get in touch with an amateur amateur radio group to work with them, and so it's kind of a networking experience.
Yeah, I mean that's amazing. I would have loved to have an opportunity like that back when I was in the university, but obviously that's amazing. Yeah. So and they reach out to the interorbital systems right away, or there's a specific department that just handles that part, or if they reach out to the main, to you.
I'm the one who answers the phone, so.
Okay, perfect.
It comes to me, and I basically talk with everyone who wants to do the project. I'll give advice, on how they might proceed, or what's possible, or there are many ways that they can arrange to buy the kits if they can't afford to do it all at once. But that's that's something that I enjoy doing.
Absolutely. I also read on your website, obviously, Randa, that Interorbital Systems is providing the lowest cost for, again, to-orbit launch, right? And what part does being vertically integrated play in that?
It's essential, because if you rely on, say you're a rocket company, okay, in quotes, a rocket company, and you're not making your own engines, which to me defines being a rocket company, right? But there are many who have to go out and buy these, incredibly strategic components to the rocket system from other vendors. Now, you have no control over what you're going to be paying for those rockets. You could be held hostage by those rocket engines, let's say. It just opens up the company to basically extortion by the people who are providing
Yeah,
the
but
light.
because it's a monopoly, right? Really, I mean, you need that.
Completely,
There's no
yeah,
way they can
completely.
charge you whatever. Yeah.
Right. So for us, it's you know, if we need to have a rocket that does a particular task, we can just, you know, build a bigger engine, combine, and you may have seen in some of our work, we're combining modules. It's a modular system. So we have identical modules, identical engines. If we need a more powerful rocket, we, you know, add components. So that's something that we can do in-house and not, you know, not have to ask anyone about it, or, you know, or beg for, you know, a low price or whatever. But it allows us to set a price point that is, you know, well below anyone else. We're looking at our next the rocket, the Scepter rocket, which we're working on now. We're looking at having that available with 50 kilogram payload to Leo, you know, for under $1 million. Now I don't know if that's happening anywhere in the world, but that's, you know, that's what we're it's our goal basically. It's kind of like we want to show it can be done.
Mm-hmm. That's awesome. And also the team again being this versatile and, you know, multidisciplinary. So do you have any specific training or upskilling programs that again you and your team are undergoing to be able to accomplish those different tasks? Because it's a lot. I mean, from the electronic components all
We
the way
learn
to
by
the
doing.
engines. Yeah.
It's all hands on. It's like you just have to immerse yourself in it, and that's the only way. I think it's the best way. It's just like, you know, you can do simulation only so long, right? But then you have to actually, in the case of a rocket, you actually have to fly it eventually and see if all that planning and everything and all training worked. But here we just dive in. We just participate. So it's if it's something that I learned to do composite work here, you know, and I hadn't done it before. You know, but it's you know, I rely on a lot of you know, historical documentation and practicing the, you know, the art of doing these builds of these composite materials. So you see what works and what doesn't work, and the only way you can find that out and develop your skills is hands-on. And we are developing. We're working with a number of universities to uh, create a job training, you know, workforce training program that Interorbital Systems hopes to be the center of here at the spaceport. So we're waiting to hear on a number of proposals we have in some National Science Foundation and some Army things that are going on that I think would really be pretty spectacular if those come to pass. But aside from that, if they don't, we still operate our own STEM outreach. We go out and teach rocket building or, you know, satellite building, and we're setting up a small training facility here for with small courses like satellite boot camp. You know, center using our own kits is the basis for the curriculum.
That's great. That's amazing. So now moving more to the again main side of things for the interorbital, which is the launchers that you have, and you're currently developing 3 different rockets, which is again the Neptune, the Trident, and Trident Heavy.
And also and also the Scepter, which is a new one.
Okay, so that's fourth one that kept
Yeah.
below my radar, right? So
But they're progressively larger versions using the same technology.
okay.
And there are many types of rockets out there now, and people find, you know, maybe halfway through their program that the propellant combination they're using and the type of engine they're using can't be scaled up to what they want. You know, it might work fine in a small situation, but trying to scale that up presents many problems. And in our case, we chose a propellant combination that, you know, frankly, I'll tell you how we chose it. As children, we used to watch the Disney space. I think it was Tomorrowland or something like that.
Yep.
So, these courses were instructed by Werner von Braun, right? So, I mean, pretty wild, kind of the voice of authority when it comes to rockets. But he would have the illustrations of how to do a mission to Mars or wherever, and the propellant combination he used always used storable propellants like and nitric acid, you know, and this made an impact on many of us who were influenced by that. So as we went through the various choices and when we started the company, you know, of how do we propel this rocket? What propellants do we use? We started with liquid oxygen and methanol, and that worked fine, you know. But then we looked at the as we scale up and we get into the whole infrastructure cost of all of this, you know, all the support systems that are needed, all the, you know, and does this have enough ISP to take us and our cargo where we need to go at a, you know, reasonable rate in terms of cost. You know, we saw that the storable propellants were the answer and on many fronts because they were standard industrial chemicals, nothing exotic, which kind of fits into our philosophy of you know, minimum cost design for everything, and subtractive design as well, taking away systems that are failure prone or too expensive. And with this the system of using the storable propellants, in our case, the white fuming nitric acid is our oxidizer, and turpentine is our propellant. These are incredibly dense liquids, and so when you fill a rocket with these, you know, dense liquids, your propellant occupies less space, so you can make a smaller rocket that has the same power. And you don't have to babysit it all the time like you do with the LOX. So you have to top LOX off to the last minute. You'll see, like when SpaceX does a launch, they keep pumping in the LOX to the last minute, and then the feed line disconnects just before launch. In our case, we you know, gas it up basically like a car. You know, you put gas in the gas tank. You fill the rocket. It can sit indefinitely and be ready to launch at a moment's notice. So that gives us an advantage of being able to do launch on demand. We can have fully fueled rockets at various points, ready to go, and you know, launch within 24 hours. That's another goal we have. So we want to use this system, which is, you know, ultra Spartan, you know, ultra simplified, and again stripped down to the essence of what a rocket is, and be able to you know, propel these payloads for, you know, pennies on the dollar compared to other companies, and you know, keep it cheap and keep space access affordable. So that's the goal, and that broadens the market for us as more people have access to the market.
So thanks again for breaking down regarding the propellant that you're using, and obviously that's smart, and that's again very convenient that you can have a rocket ready to go just anytime. And that also, as I understand, it also plays part in the rocket being more reliable as well. So there's less risk.
Yeah. Well, yeah. You have when you have less parts, there are less things to fail, right?
Yep.
So we've removed. We don't need an ignition system with this rocket. It's an auto ignition or a hypergolic ignition, and our propellants are not the incredibly, you know, dangerous ones. So like you know, a hydrazine or a nitrogen tetroxide.
Yeah, so it's not extremely flammable.
Yeah. And again, these are you have to respect them like you have to respect all rocket propellants, and you have to, you know, dress for the occasion. You know, you must wear the right protective gear. You have to know materials, you know, compatibility, all those safety features that you would use in any case. Like, you know, LOX is not the safest thing in the world either, you know. even though it's widely used. But none of these highly energetic materials are what you would call safe.
Mhm.
So yeah, it's just it's a matter of it's a balance of the performance you can get, the cost, and the safety in handling the materials.
Mhm. So what do you think about some of the more, again, futuristic and some of the more innovative designs? Let's say recently we saw Relativity Space launch their 3D printed rockets, right? So what's your opinion generally with, again, 3D printed rockets and using this innovative technologies for testing out? Obviously it's a test, but just how reliable do you believe those rockets can be long term?
Well, my opinion is that 3D printing is a buzzword that people think is a cure-all for everything. Just because it's 3D printing doesn't mean it's going to be like, the answer to everything,
Mm-hmm.
even though it's pushed as that, and it's great for investors, or, you can tell your investors, oh, 3D printing, wow, it's futuristic, whatever. I mean, we use 3D printing for some components, but never for, it's like having a continuous weld. I don't know if you've ever seen like a real-time version of the build of a 3D printed rocket is always sped up because of the agonizingly slow process that it is. That's going to be heavy. There's you notice that Relativity's launch was they didn't have a payload,
Mm-hmm.
probably because they feared it wouldn't make
Yep.
orbit, and because it was heavy. And but it's great that they got where they got to, but you saw that they've just switched over to doing non 3D printed tanks. So that's like I said, I think it's a show for investors in most cases. A lot of these systems that you can't do due diligence on, if you're an investor, are the types of things that generate the most money because they can say, well, this is this is really cutting edge technology, whatever. But there's no way to find that out, and I think simplified systems are better. Proven technology is better, and in terms of reliability, I think that's the best way to go.
Mm-hmm. Okay, that's a fair point, obviously, and I agree to that. To a big extent, obviously, we see innovation playing a good role as well, but that just requires a lot of testing and the capital upfront investment to really develop and make sure to fail-proof basically your design. So, as for example, SpaceX did, right? And even they almost failed; they were on the brink of failure in the beginning.
Sure.
Everybody knows the story, so yeah.
Mhm. Yeah.
Absolutely. So can you, Randa, now talk more about, again, the kilogram to orbit capability of some of your rockets that you're developing? And do you intend to do only rideshare or dedicated launches? And what will be, again, your perspective on that?
Our goal for all of this is manned space flight,
Mhm.
and cargo system that'll operate between Earth and Moon initially. So
Mhm.
that's what this is all leading to.
Mhm.
Uh, and the rockets that we're working on now, the Scepter, we're looking at somewhere around a 50 to 100 kilogram payload to LEO, depending on the altitude of the orbit. We're looking at using the Scepter also as to launch a very tiny payload to the moon.
Mhm.
We were in the Google Lunar X Prize. We were one of the 5 finalist teams. We were the rocket providers for the Team Synergy Moon. But and most of those other folks have already mounted their lunar missions, or they're in the process of doing like Astrobotic and Space IL and iSpace. Some of the others are they're, I think most of the people who were in that Lunar X Prize will do a lunar attempt, as we will as well.
Mhm.
We have a mission called Lunar Bullet, which is working with Ed Bell Bruno, orbital designer, and we're looking at doing a lunar direct impactor on the moon again with a small rocket carrying a very tiny payload that we call lunar station, which will as the impactor approaches the moon, it will eject the small lunar station, which will soft land with airbags on the moon, and it'll carry probably 4 experiments. So we're looking at very modest kind of a thing, but a technology demonstration. So that will be our first lunar mission, culminating eventually, and hopefully my having an espresso on the moon looking at Earthrise. So
Yeah, that's an interesting, that's a great mission, and obviously bullets, it cannot be reusable, but do you have reusability built in as part of your design for the rockets?
we have reusability in the in terms of reusing some of the components of the rockets in orbit.
Okay.
Like some of our propellant tanks, we're outfitting to be private labs or orbitals, orbiting hotels, like a private domain in orbit. Those components can also be configured into the von Braun design of the space station, the wagon wheel space station. So by putting together those propellant tank components, it could build a private space station that would have gravity in the outer, lab areas or residential areas, and then 0G in the center. So looking at that, but I really like the idea of kind of bypassing that whole thing and going directly to the lunar surface and having a lunar station there in terms of a research and tourist destination. So.
Yeah, I mean, moon has many great uses. The only problem is that on the surface, it's not really possible to have if not artificially enforced again, the plant life. So to really again develop those crops and just do the agriculture because of the day-night cycle, 28 days. Yeah.
Well, you do an underground city.
Exactly.
It'd be like living in a shopping mall, right? There are no windows there, right? So you outfit it that way, or we had always looked at the whole lava tube system as something potential to exploit there, and that is with the observation zones, obviously, strategically placed, above that complex, but that's something that is well near and dear to our hearts. Let's say we also. When we started Interorbital Systems, we also started a 501c3 called Translunar Research, and that was for the commercial exploitation of the solar system's moons, including our moon and others. And we know that that's going to be an extravagantly expensive, operation to set up again destinations, on each of these moons. So we thought we'd put it out there for a kind of a public offering, for participation in something like that. But right now, our focus is on creating the transportation system.
Yeah, and speaking about the moon, obviously, as we kind of steered off a bit of that topic as we brought it up, some of the great potential applications that I personally believe about the moon, and I want to get also your opinion. So one great application I believe would be is developing the radio telescopes on the other side of the moon, where it's where it's shielded again from all the interference coming from the Earth's radio signals. Right, so that would be a great application, I believe. Yeah, go ahead.
Yeah, absolutely, and we love that idea. And that's and I always thought instead of letting Hubble go away, we should snag it as just do a salvage operation, take that to the surface of the moon and reuse that there. But who knows?
Yeah, I mean, there have been plans to abandon Hubble many times before, so it's still not gone. So maybe there will be. I believe NASA was now just exploring the option or even reboosting the Hubble once again.
Oh, really? Well, that's great. That'd be fabulous to do.
Yeah, but that's kind of being assessed
It's
currently. They're just
like
assessing. Yeah, it's not a decision or an action plan. It's just a
right.
assessment study that they make.
I hate to see all that work expended to take something to orbit. That's why we thought about using the using our propellant tanks as like an adaptive reuse of those propellant tanks for habitats or private labs or whatever, because you've done all that work to haul that up there. So why not just keep boosting it and reuse it, or redirect it to to the lunar surface for use there.
And what's your opinion on building a launch complex on the moon to act as a kind of stop from Earth until you go again to the further deep space destinations?
We always thought that was the best thing to do. You can got a very low gravity situation there, and you've got resources there, but the in situ propellant components, and I think it's the most fabulous place for a real space station.
Yep, because again, the resources on the moon, they allow you to develop some of the propellants as well for the rockets, if we're talking about methane or hydrogen, right? So those can be developed on the moon from the resources available there.
It would be the I think it would be the easiest in terms of you've got your infrastructure platform there, which is the moon, right? So you don't have to build everything from nothing. I think it's a great idea.
Yep, that makes sense. That makes sense. So now back to interorbital systems again, Randa. So obviously, can you walk us through how hard of a process it is for launch companies to get, bypass those regulatory challenges and getting the permits for the launches? So as we understand, it's a very complex situation, and we have really seen some companies really struggle to accomplish that. So what's your take on that? How are you dealing with those challenges, and just how it works?
We had one of the first, if not the first, commercial launch licenses issued by the Office of Commercial Space Transportation in the year 2000, in October of 2000. And that was for a space altitude suborbital launch of our Tachyon rocket, which was going to launch directly from the ocean off the coast. So we've developed. We have a sea launch kind of component to the whole business plan here. We do both ocean and land launch, mobile land launch and mobile sea launch. So that process. When we worked with the AST, and they were really great to work with. I had heard all these horror stories about working with government agencies, but as I got into the process, because I did most of the work on that, the people I was working with at AST were so helpful, and they wanted to see this happen too. It's kind of their mission to promote commercial space sector, to make it doable for those people who want to engage in that sort of thing. And it was tedious, it was hard, it was answering all the the possible scenarios, and it's hard talking about the potential failures, but that you have to look at every potential failure or every potential a catastrophe that your vehicle could cause, and that's all built into the entire launch licensing process. And at that time, it was an act of Congress in order to get a launch license, and we're going to be going through the same process with our new vehicle, and I already know that it's much more complex than it was when I did it first, but that's again, it's quite a lot of time has passed, and there are quite a lot of players in the industry, and I think government really wants to be sure that people are on the level with all of this stuff, and that they know what they're dealing with in terms of the fact that these are potential destructive machines that you can do great work, but something goes awry, then bad things can happen.
I've had quite a few conversations with other launch providers, and they mentioned that obviously the SpaceX really made it easier for them as well to acquire again launch licenses, just because of demonstrating that you can reliably and safely many times over launch into space. So do you agree with that notion, Randa?
I think that everybody's success in the industry helps everyone else. And if you see a successful commercial group, that tends to wash over everyone else involved. So that's a good thing that they have ascended to the level that they have. And I knew them when they were starting too. We were all kind of doing this at the same time. And I remember visiting Elon when he had 6 people working with him. So it's quite a big step from that to now. And but no, they've led the way. There's no doubt about that. And they did some legislation had some legislation pushed through that helped commercial companies in California when he was based in California. So that was beneficial to us as well.
Yeah, and regarding SpaceX, since we are on that topic as well, it kind of always feels, and probably it is like that as well, that SpaceX is like this large Goliath that's really, again, carrying itself the majority of the launch market, and then the other companies, they tend to be kind of rivaling between each other for the second place and for the remaining size of the market. So do you see that trend anytime soon, Randa, to be changing, and do you believe other companies can really accomplish to compete again with SpaceX and even take some size of the market from them?
Well, they're pretty firmly entrenched in first place. But in our case, we're approaching this from completely the other end of the spectrum by seeing how low cost we can actually make this. I mean, even though they brought costs down, they're still building exquisite systems that are wildly expensive and well beyond the reach of many companies who might need to do on orbit experimentation or interplanetary work. So it's there's a huge gap from where we are in terms of these really low cost options for people, and then the high cost option. They will always rule in that sector of very heavy lift and prices that are less, but still not cheap, less than the prices were before. Or you could only be a country and launch. It can only be like a government entity. Now they brought it down to the level where you have to be a very, very rich company, or something along those lines in order to get a dedicated launch. But they still make it possible, and it's a good thing that they've shown that they brought the cost down relatively, enough that allows access for more people. But what we want to do is grow that customer base from people who hadn't even thought that it was possible to go to space before, to give them an option really that they can't refuse, something that is vastly affordable for them.
Yeah, great. I mean, I obviously want to take the conversation over to the SpaceX, but just the fact that they continue again to try and bring the cost even down, and obviously today the Starship test got rescheduled, so we will be looking at it either tomorrow or the day after that. So again, a big occasion for the space industry generally and launch market as well. Exciting to see that. So another thing that you mentioned in the beginning of the episode, which I really didn't want to dive into that at that moment because we had some very important topics to cover. But you mentioned that you're self-funded, right? Which means you have the clients that are willing to pay you upfront, right, for the services that you will provide them once your launchers are developed. And that means you have never raised any private funds, right? Is that correct?
No, but we decided recently that would do a small raise here in order to get a bit of speed going for the orbital demonstration launch that we intend to do next year. So we have a small offering that we've been working with a company and a group of investors on. So that will allow us to do to do the orbital launch more comfortably and at a faster pace than if we had just gone through our normal sales or contracts that we work on. So we have a lot of different revenue streams. Like we had one NASA contract, an SBIR. We have a contract with and then a NASA, what is a NASA subcontract through Paragon Space Development. We're working with them. Great to work with, great company, and a number of other projects and programs, bizarre advertising projects, and all sorts of interesting things. But these are all revenue streams that come in to us. However, that's it's sporadic, and it sometimes slows the pace when we'd rather go faster. So the investment group we're working with now, I think will provide a bit of needed acceleration, let's say, to the program, so that we can. I believe it's important now to do the launch, like within a year is what we're looking at, to do that orbital launch. We've already launched the prototypes of the booster stage of the rocket and the propulsion that'll be used on the upper stage. So those components have already flown, and there are numerous videos that are linked from our website, interorbital.com. If you scroll down that front page, it'll take you to all the testing and flights and things of that nature. But so we've come a long way on our own, under our own steam, as it were. But I think to make it happen in a timely manner, and I think the time is right now for that cost vehicle.
Yeah, and I believe you're doing a great job, and you're basically breaking this misconception that the space companies, they're like highly, cash intensive, that they require a lot of upfront investment, which again you're proving again that that's not the case, and it's possible to be even self-sufficient just by having this great, again, design and a great value proposition that you will be offering to the market. And that's amazing to see that the clients are also willing, again, to be open to that and just grab onto that opportunity.
Yeah. They can't get a launch at that cost anywhere.
Yep. I think we have a small connection issue. Yeah, now it's restored. Yeah, good. So now we're restored. Yep, I'll edit that out. Our team will edit that out. Don't worry about that. Yeah. Okay, great. So the next question again, Randa. So as you now have this raising round also open at the moment, right? And you mentioned you already have a investor team that you're working with. Are you open for propositions from other private investors or VCs? That would be
yes, accredited investors. We are, yeah. And again, it's something we avoided because we didn't want to just do the standard thing that we've seen reoccur so many times and fail. That the company gets many millions. They hire a couple of hundred people. They build a building. They do all the things that other than usually the R&D that's required. So it's an R&D program we have to go through, and basically look at those companies as, okay, they're amateur rocketeers with a huge war chest, of cash, but they still have to go through that R&D, phase, all that development, and that is, believe me, it's not easy, and it requires a good amount of time to get things right. So and with a rocket, it has to be working 100%, or that's it. So it's
small room for error, right?
not much, not much.
Exactly. So for, let's say, some potential investors or VCs that are watching this at the moment, so they might be looking at this at a later stage, obviously, because this is again on the YouTube and on everywhere on the podcasts hostings. By when are you looking to close the round? And yeah,
they can call me and we can discuss it.
Mhm.
It's ongoing right now. So
Okay. And do you have any deadline when you plan to conclude the round? No. So it's
but I'd like to do it as soon as possible, you know,
Mhm.
and that is you know, all I can say about the company is we are the definition of lean,
Mhm.
and and when I reveal when we do orbit and I reveal the amount of money this cost, no one will believe it. Okay, you know, the small figure that we were able to achieve this with,
Mhm.
what we've done so far, you know, so it's going to be astonishing. We can only any investment now I think would be a growth type of deal without
A
any.
cherry on the cake, right?
It's so, I mean, we've like I said, we've done this, all the R&D hurdles. We've done this, you know, this massive uh, reduction of systems on the rocket to create this vehicle, which is beautifully simple, yeah, in its way. And this is the answer to many business plans out there of, you know, they may have a great satellite system or, you know, on orbit refueling or whatever, but they need the inexpensive rapid response rocket that we will provide very shortly.
Mhm. Wonderful. And again, we'll be supporting you, and we'll be cheering you on your journey. And again, looking forward to how this exciting again project and the phase of yours will turn out to be. And we hope it's going to be as successful as you want it and even more. As for the potential investors or the clients that are watching this, again, they have a funding round currently opened until further notice. They have already the capabilities that will be ready by the end of 24, as Randa mentioned. So make sure to reach out to them. Their website is Interorbital. Let me not confuse that. So interorbital.com. That's their
Yes.
website. Make sure to check it out and reach out to Randa as well. You'll find her contact info there. Yeah, if you're watching this on YouTube, make sure to subscribe and stay tuned for further episodes that will be coming out. If you're listening to the Apple Podcast again, you know what to do. So thank you, Randa, again for joining us today.